Welcome to part E, which also deals with inheritance, but in this part we're going to do some practical examples, and you'll see that we'll have multiple levels of inheritance where a child will inherit from the parent, and that child will itself become a parent when it passes on the inheritance onto another child. So let's get stuck into inheritance examples. So this is our plan. We're going to create a superclass called Portal, and then we're going to create two subclasses of Portal: Nice Door and Nice Window. We are not going to make any objects of this type called Portal. We are only going to make some objects of type Nice Door and of this class called Nice Window. So once we've created the class Nice Door and Nice Window, we will make some objects of this class. What we'll also do is we'll create a subclass of this subclass where this is the child and that's the parent class. So we'll create a new subclass of this class called Nice Door. So you'll get a good view or a good understanding of multiple levels of inheritance or inheritance hierarchy. So let's get into it. Let's first now create the parent class or the superclass called Portal. So here I'm defining a class called Portal with a keyword class, and I'm also going to define its properties, the same properties we dealt with in previous parts: opened, locked, which I'm initializing to false, width, height, weight, and color. And I'm going to add a new property called name of type string. The reason why I want to add this property is because I want to make windows and doors from this Portal class. So the name will either be a window or a door, and that will not come at this stage. It will come in the subclassing stage. Good. Now whenever you create classes, I said to you, you always need to put in an init method that's going to give objects of this type its default values. So I'm creating an init method that's going to initialize the 5 properties: color, weight, height, width. And you'll notice that the new property that I created, I cannot initialize it here because I'm not too sure whether it's going to be a door or a window. So I cannot initialize it here. This initialization of the name property will happen in the subclass, which you'll see later. So that's the reason why I don't have an initial value, because at this stage I'm not sure whether it's going to be a door or window. We're taking in the input parameters and initializing the property. That's what's happening here. And we use the keyword self to differentiate between what the input parameter is and the property. So this here in black is the input parameter to the init method, and this here is the actual property of the class or the object of this class. Now the methods are the same as we previously had. We have an open method to open a closed door. We have a close method to close an open door. And we have a lock method to lock an unlocked door. And we also have an unlock method as well. So that's the end of that class definition. We haven't made any objects of it. We don't need to. We're going to try and subclass this portal now. So at this stage, we have created this parent class or superclass. Now we're going to make two subclasses of this class, one called nice door and the other one called nice window. And then we're going to make some objects and show you how the inheritance works. Okay, let's come down here. Now I'm creating a subclass called nice door, and it's going to inherit from the superclass called portal. So you use a colon and you type in the superclass name here. So this is the child class and this is the parent class. Once that is done, inheritance comes into effect, where nice door is going to inherit all of the properties and all of the methods from the parent, from portal. So in nice door, the only thing I have is an init method. Now why do I have an init method here and I have an init method here? This init method is the superclass's init method. Can you see different values here? Okay. But this init method is the init method of nice door. And we would like to initialize, because it's a door, we'd like to set new default values for it. See, it's a rectangular door, so the width will be 32 and the height will be 72, higher than longer than the width. So we'd like to set the initial values of nice door, which are different from portal. So that's why nice door has its own init method. But whenever you create your own init method within the subclass, at the end of your init method, you have to call the superclass's init method to initialize all of the variables at once. So nice door is supplying these values to the object, and we are then passing these values to the superclass's init method, and we're also passing the name, whether it's a door or a window. So at this stage, when a new nice door is created, it would be initialized with all of its parameters or all of its properties, including the name. And in this case, the name is door. So what have we done so far? We've created a subclass called nice door from this superclass called portal. We haven't made any objects yet. Now let's make another subclass of portal. That's what we are doing here. We are creating a new subclass called nice window from the superclass called portal. So nice window is going to inherit all the properties and all of the methods from portal, but we would like to create our own init method, because a window has different default values to a door. A window is more square rather than rectangle. So that's why we have the width and the height the same value here, and we can set our own color. So in this init method, it initializes, it takes in some parameters. It then calls the superclasses init method, takes in these parameters and passes it across, and also initializes name to window. Okay, so now we've completed the portal, we've completed the nice door class, subclass, and the nice window subclass. Let's try and make some objects now from these subclasses called nice door and nice window. Okay. Now making an object called sunroom door from this subclass called nice door. Notice that open and close was never defined in nice door. It was defined in the class above it. So that's how inheritance comes into play. I can use close and open on sunroom door, which is a nice door, but close and open and lock and unlock was not defined in this class. It was defined in the class above it. So nice door as inherited, or this object called sunroom door of class nice door has inherited these methods. So I try to close the sunroom door, it executes. I try to open it, I try to lock it, try to unlock it. I can also check what the status is of some of the properties of sunroom door. Here again, locked and opened were inherited from the superclass. I can also check what the width, height, and weight is. Inheritance is coming into play here. Let's make an object of type nice window. So I'm creating an object of type nice window, or class nice window. The object that I'm trying to make is called the bay window, and this is the class. I can open the bay window, close it, I can lock it, unlock it. I can check the status of its properties. It's locked, opened, width, height, and weight. And all of these methods and all of these properties were inherited from the superclass. Now we will go one step further in the inheritance hierarchy. We will try and make a subclass of a subclass. The new subclass that we are going to make is called combination door, and you'll also notice that combination door is a nice door, and nice door is a portal, and nice window is a portal. I mentioned to you in the previous part, there must be a relationship. There must be some similarities between the child and the parent. So let's create this combination door. Now a regular door that we've been creating so far has a lock or latch that can be locked or unlocked. But some of these newer, fancier doors don't have latches or locks. They have a keypad or combination lock where you have to put in a secret code, a 4-digit code, and then you'll be able to open the door. Or if you want to close the door, you put in the 4-digit code, the right combination, and you can close the door. So opening and closing of the door is not done by locking or latching it. It's going to be done by entering a code. basically a string of digits. So I'm making a new subclass called combination door. It is going to inherit from nice door. So it's going to inherit all the properties and all of the methods from nice door, and nice door would have inherited all of the properties and all of the methods from the portal class. Multiple levels of inheritance. Now I'm introducing a new property here. Besides the properties that it's inherited from its parents, I'm creating a new property here in this subclass called combination code, and I'm giving the type string ? If you'll remember from previous lessons, I think it was lesson 2 or lesson 3, we studied optionals, where we put a question mark at the end of the type, the data type. What is the purpose of that? It means that we could have a combination code, or we may not have a combination code. We may have a value in it, or we may not have a value. It's optional. We don't have to have a value. Good. Now in inheritance, we cannot inherit some of the properties or some of the methods. Inheritance gives us all of the methods and all of the properties. We cannot choose which ones we want and which ones we don't want. We get by default, we get all the properties and all the methods. Now sometimes you may not want to have a certain method in its present form. You want to override that method. You want to redefine the method with the same name. So you want to cancel off the old method and put a new code into the new method with the same name. So this is how we override a method. We type in, I would like to override the lock method, and I would like to override the unlock method. Because the traditional locking and unlocking is not present in the combination door. We would like to make new lock methods and new unlock methods. So to override a function, type in override and the name of the function, and put down some code that you want to execute if this function is called. So if you try and call the lock function in combination door, it should give you this message: this method is not valid for a combination door. Or if you try to unlock a combination door using the traditional latch, it should give you this message. So we're overriding two functions. Now that we've overridden these two functions or methods called lock and unlock, we now need to create our own lock method and own unlock method. And that's what we do here. Okay. And in this new, so we've overridden the previous lock method, and we're going to introduce a new lock method, because this new lock method is specific to this combination door, because it's going to accept a combination code of 6 digits, and if the combination code is correct, it's going to check that the combination code is correct. It's then going to lock the door. If the combination code is incorrect, it's going to say your code is incorrect. Yeah. Down here. We can also unlock the door with a combination code. So this unlock method is going to take in a string, which is going to be the 4-digit code, and it's going to compare it against what the right code is, and then it's going to unlock the door with this code. Let's test it. So I've created my new class called combination door. Now I'm going to make new objects of this class, combination door, just to test inheritance works and also to test whether the overriding of the functions work. So I'm creating a security door of class combination door that would have inherited all the methods and properties from niceDoor, which would have inherited all the methods and properties from the portal. I check its width, I check its height, I can check its weight. And these default properties were got from the parent. I can also check what the color is, and at this stage the combination code is nothing. It's null. We didn't put any combination code in yet, and that's where the optional comes in. We could have a code, or we don't have to have a code. So its initial value is nothing, blank, null. Let's try and unlock the door in the traditional way. So we say unlock, we don't send any parameters. It's then going to give us this message: this method is not valid for combination door. Because we have overridden the code in here, it's not going to unlock the door using this method called unlock, open bracket, close bracket, because we've defined a new method called unlock that requires a code, which we'll use later. Then we try to lock the door using the old lock method. It should give us this error message. Now we try and unlock the door with our new unlock method, and we pass the code 6809. It doesn't allow us to unlock the door because the door is already unlocked. Let's try and lock the door with the code. It locks the door. Let's try and use a wrong code to unlock the door. It should give us this error message, and let's try and use the correct code to unlock the door, and it will then unlock the door for us. Hope you enjoyed this part that illustrated how we have multiple levels of inheritance from parent to child, and that child could also become a parent to a subclass below it.